Hello everyone. Um, this week seems to be Johnson week. Had a Valiant on the bench last week. Didn't get no video recorded on it, and we have another one on the bench this week. And we're gonna walk through a few problems. One thing, just like the other one I walked on, there was some sizzling going on in there, and some smoking and all kinds of weird things. You know, it's never good to let the smoke out of something. But this is something that someone else had walked on before, and they've done a few things to it that ain't quite right. So we're going to get together on this and go through some of the problems and see if we can't find out, just what's been done to it, and try to get it back on the air, because this is, a good classic rig. Now, I'm going to tell you, you don't need a whole lot of test equipment. You don't need a whole lot of knowledge. What you do need to do is be able to read and understand. Now, I'm going to tell you, there are lethal voltage in this transmitter. So if you're working on one of these for the first time, be careful. There's voltages in here that can hurt you mighty bad or even kill you. So if you're playing alone, you're doing so at your own risk. The rule about keeping one hand in your pocket, it don't always work. One hand is all it takes to get a hold of something that really can mess you up for life. But the first thing you need to do is you get ready to walk on something like this. You're not that experienced. Download the manual, and you can go through the manual and find all kinds of good information, on everything that's going on. They got an excellent theory of operation in this manual, and it just about tells you everything you need to know. Go in, test voltages, get rid of the old caps that are in there. They're always a problem. So sit back and we'll troubleshoot through this rig and see can't we get it going. Hope you enjoy it. Also, I'm going to surprise him because he didn't say nothing about it. But if you noticed on the knobs, these little white nubs that stick out, this one is missing in quite a few of the knobs. And thanks to Terry over at D-Lab, we already have a fix for that. These are little pins out of Deutsch connectors that I was able to pick up because he supplied the part numbers. And we'll be installing those in these and cutting them off to the right length and getting that looking a lot better for the owner. So let's go ahead and put this thing up on the side. I'll get the case off, and we'll see if we can figure out what was sizzling inside this thing. Okay, we're bottom side here, and you can always see that all the electrolytics have been replaced. These capacitors down here have not been replaced, so we'll probably go ahead and replace those. There's another one stuck up here, but we got to wonder about what's going on over here in this power supply, and where's that sizzling coming from. So we're looking at our schematic here. We can see that this is our primary side and these are the secondary sides. Well, here is our high voltage, and you see these 866 rectifiers, and they have a lot of problem with these arcing from the filament leads to ground. So we're going to check in this area and see if we see anything, because this is mostly in this section right here where these problems arise. Whenever you hear something frying inside of one of these rigs, if it's not the Chernobyl resistor, this is another good place to go ahead and look. Is right off your rectifiers. So the area we're going to be looking in is going to be right up in here, and we can see our high voltage leads coming off here, and I'm already seeing a problem there. You can see the end of these leads, which go up to the top of the tube, or melted a little bit. But down here you can see there's a ball of solder, and it looks like it's arcing directly to ground. You can see how black this little terminal board has already turned. And a little bit better view. Yep, you can definitely see she's been arcing in there. So we're going to have to get this out, replace that terminal board. We'll get something that will separate that a little bit better and get it away from ground. I got the old terminal board out, and you can see it was really doing some arcing in there, and that is never a good thing. Let's hope nothing else got damaged in the process. But we'll go ahead and get a new board stuck in there and get those leads spaced away so they can be on ground or near ground potential anymore, because this is a common problem that we have seen in these rigs. And you can see it was just having a good time like a welder in there. Okay, when we put the rig back together, I decided to go ahead and do a little testing off camera, and I was still hearing some more frying going on. So I went in and started checking some voltage, and all of a sudden I saw a plume of smoke. And the first thing I thought it was this big power transformer, and the way the smoke was coming up from it. But that's not what it was. We were lucky this time. And what I found was on the bottom of this RF choke, this is L11, and here on the bottom of it, let me get the camera right. Okay, so right here on the bottom of L11 we have another choke here. This is L12. See that nice pretty crack in there? Yep, that choke is done for. So we'll have to get this replaced. So I happen to have another choke just like the one that was in here. It's probably the same vintage. It checks good. This is the old one, with the burnt spot in it. And as you can see, the one that I put in here is identical. Like I say, it's probably the same vintage. I had a bunch of these in my junk box. And this one here was never used, and see it's beat up, looks just like the one that was in it. But the first thing you got to wonder is, okay, why did this choke burn up? What made it go nuclear and smoke out? So my first suspicion is going to be these capacitors here. Let me get the old analog meter here so you can see it. That one checks good. And there we go. Yep, that one's a complete short to ground. I love an old analog meter, and it's cheap. And the reason why I use these is because if you blow the meter up, you only out a couple of bucks. These came from Agri Supply. I think it was like $4 and something for the meter. But it's good just for doing little tests, and checking some DC voltages that are a little higher that I don't like to put my digital meters in. So yes, so this cap right here is shorted, so we're gonna have to replace that, and I'll probably go ahead and replace both of them. Okay, with just a handful of little parts, we've got the Viking fired up, and we'll go ahead and see what's going on now. So I'll go ahead and throw it in transmit. And we'll go over here and we'll hit the key and dip our plate. And she is back on the air again. Just a few little small things that have to be done. Arcing on a terminal strip. Blowed out L12, which is a choke under the main RF choke, due to a pair of bad caps. You don't see a lot of ceramic disc go bad, but when it comes into the RF circuit and with the voltage and RF applied, this can happen. Okay, so I thought we were going to need the bottom and start doing a little inspection. You know, we had the problem up here with the arcing, which is now fixed. So we got a terminal board installed. We got some silicone insulation tubing over the leads, and the high voltages are spaced out. They're further from the chassis, so that, you know, takes a chance of arcing away. One other problem we got to address is this cam mechanism here. He only uses it on 160, so when he goes to other bands, we go all the way to 20, but going down to 10 meters, it won't go in because our pins are misaligning. And I don't think it's just a problem where the cams are off. It's just this part of the cam is real tight, and it shouldn't be that tight, and that's probably what's thrown it off. And the bad thing to get into that, to take care of it, is having to take the VFO covers off, which is a real pain. But that's how you get in there to do it. But you know, we need to check that 18K Chernobyl resistor too, and he said it's been replaced, but we want to be sure. But you know, searching around here, and I come across this. You see we got 3 caps that are tied to ground and going to various circuits, and I noticed this. Yep. It looks like this lead broke and someone tried to resolder it, and you just, if the lead breaks off flush with the ground side of these caps, you cannot solder them back on. You know, it's when you need to go ahead and spend the extra time to put a new cap in and put it in properly. So yeah, that's got to be replaced. So what I want to show you here, this is our main filter caps for the low voltage supply, and as you can see, they have done this entirely different. You know, it's just completely wrong. It shouldn't be done like this. This is supposed to be two 15 microfarads at 450 volts, and what they've done, they've got one 10 microfarad on one side, and they got a 10 and a 22 microfarad in parallel on the other side, and that is just wrong. So if we look at our schematic, we can see V20 here, and these are those two 15 microfarad capacitors, and you see they come from either side of L44, which is the choke, and they go to ground. Now this side they've done right. It's in fact, they use 20 microfarads at 450, which is fine. I wouldn't go much over 20 microfarads because you don't want to load down the supply. But this is on the negative supply side, and this is the positive supply for the 300 volts. So we need to replace those capacitors with the correct value, and that should take care of that problem. Sometimes, you know, people do things in a pinch, and it's not always right. Okay, now that we got rid of this abomination that was just hanging underneath the tube sockets, I put in a terminal strip and mounted the two new 15 microfarad caps in, and wired them to the tube socket. Next place we need to look down here is just behind this transformer is another paper electrolytic It's 10 microfarad at 25 volts. We need to get rid of this. And I don't know if you can see this. See, there's the long ground lead coming from it, and it's right up against this tube socket pin right here. And this was, you know, it's been in there since the radio's been built. This is a hand-built unit, and again, the way you tell is you look at the tube sockets, and they have nuts and not rivets. Factory wired units had rivets in the tube sockets. So when they built this, that could have been a failure that may have caused some problems down the road for 50 years. You know, it's luckily that hasn't shorted out. But this is in the audio circuit, so we definitely need to get rid of that capacitor. And there's the old 10 microfarad cap at 25 volts. We won't even worry about testing these things. But there's the new modern replacement. You can fit 15 of these in the space that one capacitor taking up. Technology has really advanced so much, you know, little tiny electrolytic compared to these big old dinosaurs. But she's in place, sitting right over here under the tube socket. Don't have to worry about gluing that down or nothing because it's so light, and it won't be flopping around. So that'll take care of the capacitors. Now, next thing we need to move on is that band switch cam, and see what we can do about that. Okay, I took the side cover off the VFO compartment, and I can tell someone has been in there before because the two screws on these bottom posts that go through the chassis were missing. So someone has been in there, and at this time, you know, I'm really wondering the hours that's been put on this transmitter, and I really believe the hours are a little bit low. And one reason why I say that is that you can see this 5-watt carbon comp resistor in there. That's Mr. Chernobyl, and he looks good, not heated up or anything. So it looks like it still has the original resistor that was you know, put in when the thing was built. The thing is, it's got to go. We got to get that out. Put a 10-watt one back in there, and that should take care of any future problems inside this VFO. And sitting way back there in the back, you can see that ceramic wafer right there. That's the other part of the band switch, and as you can see, we cannot get to it from this side. So I'm going to try to get this off without pulling the front panel off. And the only thing that's probably going to hold me up is these two brackets right here. I'm hoping, you know, I can loosen up this screw without getting the nut off of it and turn them out so we can lift this straight up, and hopefully in between these two pieces when they're sitting in the vertical way. But we'll have to take the rest of the screws off the bottom to try to raise this thing out without you know, I do not want to take the front panel off. That is a lot of work. So we'll see if we can get this out without doing that. Well, as you can see here now, with the cover removed from the VFO compartment, we can now see that wafer switch directly under here. It's still a little tough to get to, but maybe now, you know, we can at least try to get to it and see if we can get it freed up a little bit, because it's very stiff, and what it is, it's probably grease underneath of it that is hardened up. So what we have to do is wash it out and put some new lubricant on it. Alright, this is a tough angle to show you, but what I've done was took some tuna wash and cleaned out that switch down there in the bottom. And what I use it to lubricate it with is some Blaster. It's a advanced dry lube, and it has Teflon in it. So let's see how our switch turns now. Okay, before, you know, I could barely turn it, and look at that. It is completely free now. So by washing it out with some tuna cleaner and then spraying it with that dry Teflon. And the good thing about the dry Teflon, it doesn't leave a wet film, so dust and, you know, particles doesn't stick to it. It dries to, you know, it's dry to the touch, but it's got Teflon in it, and that just works a treat. I still have to work on getting the cam lined up, but as you can see, even now, it's working without any problems. So I might not even have to touch that cam. Now, one thing I will do is put some moly paste on these pins, so it'll slide through that a little better. Now, when putting the top back on the VFO cover, you got these little wires that align with the capacitors, and sometimes they'll fall off as you're trying to put them in. So just put a little drop of adhesive on this side with a flat saw and let it sit, and now you don't have to worry about these falling off when you go to reinstall this. So once you get the cover on, you get all the adjustments lined up, you want to tighten up these screws again. Now you got to remember there's a nut on the other side of this that you can't get to. So to tighten these up, you just grab the bracket and pull it to you. That'll hold the nut. Let me get the right screwdriver. That'll hold the nut up against the front plate. Then you can tighten the screw back up. When you take these off, you know, don't loosen them up a lot. Just enough to swing them out of the way. Now that bracket's good and tight. And we can go ahead and put the nuts on the bottom of the cage. That'll hold this down, because you know, these are spring loaded, and if you go and try to push them in, you might pull up on that. Now if you're working on one of these and you take it apart and check that 18K resistor and find out that it's okay, and you really don't have a good replacement, what you can do is on the bottom of this plate, you can mill you out a little slot and run 2 wires out, remove the resistor, and mount the resistor down here on the chassis, and this way the resistor is easy to get to, and it will not cause any change in the way the VFO works. Some people say they like to keep the resistor in it because it warms up and keeps the VFO stable. The resistor should not be getting that hot. Not enough to make a difference inside the VFO. The tubes will keep things warm in there. Like I say, if you're going to run a 5-watt resistor and you don't have a 10-watt replacement, then mount it outside here on the chassis. That'll save you some time. If it ever does go out, it's not going to burn up everything in the VFO compartment, and it'll be real easy to get to. Well, the Viking Valiant is all back together, and checked it out. Checks out real good. Got the microphone on. Test 1 2 1 2. Sounds real good. Good clear audio. Great AM radio. Yep, so she's all ready to go back to the owner. Hope you enjoyed this video, and as you can see, it wasn't that hard just to troubleshoot the little problems with it. Just, you know, take the time and go through it and see what you can find. Anyway, leave your comments down below. I'll leave links to the website, and if you want to discuss this on the website, and links to Patreon and a few other things down below. So hope you enjoyed it, and we'll see you in the next video.